Okay, the last thing that we need to talk about are horizontal and vertical translations. Okay, when we talk about a horizontal translation with regards to sine and cosine functions, we call it a phase shift. Okay, so I'm going to write in standard form sine and cosine. Okay, but I'm going to change it up just a little bit, and I'm going to add in a horizontal and a vertical translation, okay, or a phase shift. So I'm going to write this y equals a sine b times x minus h plus k. This is a little bit more what we're used to seeing when we've talked about horizontal and vertical translations. This is always our horizontal, right? This is our vertical. I'm going to write cosine the same way. Okay, so this right here, right, h is our horizontal translation. But we're going to call it, since we're working with sine and cosine functions, a phase shift. Okay, k is our vertical translation. Okay, and we don't have any new terminology for that, so we're just going to call it a vertical translation. Okay, so when we write sine and cosine, okay, in standard form, like this, our period is still 2 pi over the absolute value of b. The frequency is still the reciprocal of the period, absolute value of b over 2 pi. Okay, my amplitude does not change either. That's still the absolute value of a. The phase shift is h, and the vertical translation is k. Okay, so last example, example 5. Okay, we're going to state the amplitude, period, phase shift, and vertical translation. Okay, so let's start by looking at y equals -3 sine of x minus pi over 10. Okay, so when we are trying to figure out the phase shift, okay, and the vertical translation, we need to write the function like this. Okay, and in order to do that, we are always going to factor out the number in front of x. In this case, the number in front of x is just 1. Okay, so that doesn't really change anything. I'm just factoring out that 1. The amplitude is the absolute value of a, so it's 3. Okay, the period is 2 pi over b. Let me label these real quick. So here's a, here's b, here's h. Okay, and technically there's a +0 out here. That's my k. Okay, so anyways, my period is 2 pi over 1, which is 2 pi. Okay, my phase shift is h. Okay, in standard form, it's x minus h. Because it's x minus h, I always have to change this sign. So since it's x minus pi over 10, that means that h is pi over 10. Okay, so with the phase shift, I'm just listing this as a value. I mean, technically, right, I'm shifting this graph right, pi over 10 units. But that's not what we're going to write here. We're just going to write the values, pi over 10. Okay, and my vertical translation is 0 because there's not a number on the end of that function. Okay, let's look at letter B. Y equals 6 sine of 2x plus pi over 4 minus 2. Okay, so to write this in standard form so that I can pull out that phase shift, I always have to factor out the number in front of x. Okay, the number in front of x is 2, so I need to factor out 2 from this expression. Factoring means dividing. Okay, so I'm taking 2x divided by 2, which is 1. Okay, and that's what I want it to be. I want this coefficient to be 1. Pi over 4 divided by 2 is pi over 8. Okay, remember to do this. We take the numerator, we multiply by the reciprocal of the denominator. It's pi over 8. Okay, so here's my A, here's my B, here's my H, here is my K. Okay, so amplitude is the absolute value of A, so that's positive 6. Period is 2 pi over B. B is 2, so that, or the absolute value of 2. So that's pi. Okay, my phase shift, I've got to change the sign. This is plus pi over 8, so my phase shift is negative pi over 8, right? When we add, we're technically moving to the left. And then my vertical translation, I'm taking that minus 2 on the end of my function, which means that I am shifting my function down 2 units. Okay, letter C. So I have y equals 3 cosine 4 pi x plus 2. All right, so to write it in standard form, the first thing I need to do is factor out the number in front of x. Okay, so it's just 4 pi, so I'm going to factor 4 pi out of there. Okay, this is the same thing, and I'm just writing this. You don't have to write it this way. I just want you to see what's going on here. This is the same thing as x plus 0, and the reason that matters is that this is A, this is B. That means that h is 0 and k is positive 2. Okay, so my amplitude here is the absolute value of A, so that's 3. Okay, my period is 2 pi over B, so 2 pi over 4 pi, that's 1/2. My phase shift is 0, and my vertical translation is up 2 units. Okay, last one. Let's say that we have y equals 3/4 cosine of x plus 2 divided by 3 minus 1. Okay, so I'm going to rewrite this a couple different times. The first thing I'm going to do here is separate out these fractions. Okay, x plus 2 over 3 is the same thing as x over 3 plus 2 over 3. Okay, and x over 3 is the same thing as 1/3 x plus 2/3. Okay, now to write this in standard form, I need to factor out the number in front of x, and the number in front of x is 1/3. So I have 3/4 cosine of 1/3 times x plus, okay, this is division, right? 1/3 x divided by 1/3 is 1. 2/3 divided by 1/3 is 2/3 times 3 over 1. These cancel, so that's 2. Okay, so then if I label, I've got A, B, H, and K. Okay, so my amplitude is 3/4. My period is 2 pi over 1/3, which is 2 pi times the reciprocal, 3, which is 6 pi. Okay, my phase shift is -2, and my vertical translation is down.